we continue to keep a close eye on 3I Atlas, an interstellar object the size of Manhattan that is believed to be a comet that is getting closer to Earth. Check out these new images of the object, which appears to have lost its tail. Some scientists are now theorizing that this is new evidence that 3I Atlas is not a comet, but a possible alien spacecraft. The James Webb Space Telescope has once again reshaped our understanding of the universe, when its instruments discovered the interstellar object designated 3I Atlas. Astronomers initially assumed it would resemble other known rogue objects such as Oumuamua, and 2I Borisov, small bodies of ice or rock that have been ejected from their parent systems, drifting between stars. But when Webb's infrared eyes began capturing detailed spectra and images, the data reveals something utterly unexpected. 3I Atlas was much larger than anyone had anticipated. What was thought to be a modest interstellar traveler turned out to be a celestial body of staggering proportions, so massive that it challenged our assumptions about how such bodies could exist, let alone survive the violent thrust from a planetary system into the interstellar void. Stay tuned, because what happens next will blow your mind. If you are fascinated by the mystery of 3I Atlas and want to see more amazing cosmic stories, hit that like button and let the universe know you are watching. Every click helps keep the quest for the unknown alive. Comment below and let me know where you are watching this video from. I want to see what corners of the world are witnessing this along with me. The first observations really took off when 3I Atlas came into clear view with Webb's ground-based telescopes in NOT. The object started out as a dim, a few kilometers across, but when Webb took deep infrared images, the bright dot revealed itself as a giant structure with unusually strong heat reflections and emissions. Analysis of the brightness suggested that 3I Atlas could be hundreds of kilometers in diameter, larger than any known interstellar visitor. The discovery is shocking because it's virtually impossible for such large objects to be ejected from their star systems. Some scientists have suggested that 3I Atlas could be the remains of a shattered dwarf planet or the core of a protoplanet ripped from its parent system in a cataclysmic event. Webb spectrum supports that theory, a mix of ices, silicates, metals, and even organic molecules, but in unusual proportions, suggesting a formation environment richer in radiation and a different chemistry than our solar system. Mary also detected ammonia, hydrates, and carbon compounds that suggest the object once experienced intense internal heating or tidal action. This suggests that 3I Atlas is not a primitive comet or asteroid, but rather the remains of a once geologically active world, a failed planet drifting in interstellar space. If such a large object could be ejected from a star system, it forces planet formation models to consider catastrophic interactions or unknown mechanisms. Young star clusters where chaotic gravitational interactions occur frequently are considered candidates for his origin. 3I Atlas may contain the frozen memory of a chaotic stellar nursery. Webb's observations also revealed a thin coma surrounding the object, which irregularly jetted out in traces of cracks or areas where the surface had been torn apart. In the past, from these jets, scientists measured its slow rotation rate, a rotation every few days. The slow rotation and large mass suggest that this is a monolithic mass stable enough to survive billions of years in interstellar space. 3I Atlas is thus becoming one of the clearest clues that between the stars may drift countless remnants of once existing but destroyed worlds. Planetary fossils silently carrying the untold stories of distant star systems. The implications of 3I Atlas for the exchange of matter between star systems are profound. If such massive debris is indeed common, the universe may be experiencing a continuous interstellar flow where stray planetary remnants seed young star systems, with complex materials helping to shape the chemical composition and even the precursors to life of protoplanetary disk. As these giants pass through a planetary system, they may bring with them exotic compounds or unprecedented isotope ratios, directly influencing the formation of planetary atmospheres and structures. Using Webb's data, researchers simulated 3I Atlas's internal structure and deduced that its density could only be consistent with a dense, rocky core surrounded by layers of ice and dust. This configuration, similar to icy moons like Europa or Enceladus, opens up the tantalizing hypothesis that 3I Atlas may once have belonged to a world with a subsurface ocean. If true, interstellar space could be filled with debris from once warm worlds, perhaps even environments suitable for prebiotic chemistry, a prospect that has left the public fascinated and the scientific community extremely cautious. International teams are now synchronizing Webb's data with models of light, radiation, and reflection from icy objects to verify every detail. Every analysis points to the same conclusion. 3I Atlas dwarfs any interstellar visitor yet recorded, both in size and complexity. The timing of this discovery was particularly fortunate. Webb had already demonstrated its ability to observe exoplanet atmospheres in the early universe, but direct access to a large interstellar object close to the solar system was a new frontier, bridging the gap between the study of distant worlds and the tangible relics that drifted into our cosmic backyard. As 3I Atlas moved closer to the Sun, Webb recorded sublimation events that revealed the distribution of volatiles, including jets rich in polycyclic aromatic hydrocarbons and nitriles, important precursors to amino acids. This was the first time such compounds had been detected on an interstellar body. The presence of these complex organic molecules immediately reignited the panspermia debate. Could the seeds of life have traveled across the galaxy via debris like 3I Atlas? While the conditions on this object are unlikely to sustain life, the fact that it carries biological precursors makes the idea hard to ignore. Clumps of matter that have been wandering through space for millions of years, like 3I Atlas, could have been primordial cargo ships quietly delivering the essential ingredients for biology wherever they go. For planetary scientists, the surface structure of 3I Atlas tells an equally fascinating story. Smooth, bright areas interspersed with dark and deeply dimpled areas suggest impacts and resurfacing that occurred long ago, perhaps when the object was still in orbit around its parent star. Some theorize that it was once impacted by a dense ring system or bombarded by small moons and asteroids. The craters and fissures visible in Webb's infrared images paint a picture of a world that was battered by cosmic violence before being flung into interstellar space. Spectroscopic data from Webb also showed signs of crystalline ice, the kind that only forms after long periods of warming and cooling. Its presence suggests that 3I Atlas was exposed to relatively high temperatures, possibly from internal heating or orbiting close to its host star. This reinforces the idea that it was once part of a complex planetary system, possibly even in the region where liquid water could exist. The sheer scale of 3I Atlas also forced researchers to consider the possibility of countless similar objects silently drifting between the stars because they reflect very little light and move slowly against the stellar background. Most of these wanderers would be nearly invisible unless they pass close to the solar system. The discovery of 3I Atlas suggests that interstellar space is not an endless void, but a region filled with ancient fragments of lost worlds from past generations of stars. A growing number of researchers are calling objects like 3I Atlas wandering relics, intact fragments of failed planets that carry the chemical signatures of distant star systems. Each one is like a sample return mission from elsewhere in the Milky Way. But without requiring humans to leave the solar system, what's particularly intriguing is the energy required to eject such a large object. Models suggest that interacting with a gas giant isn't enough. Instead, a binary star system could create a gravitational kick so powerful that it rips it from its parent system and flings it into interstellar space, explaining its unusually high velocity compared to other interstellar visitors observed. Webb's resolution also allowed us to spot faint dust trails escaping from 3I Atlas. Optical analysis revealed that these grains had isotopic ratios, significantly different from those of solar system materials, suggesting an origin from a star with more metal content and a different oxygen-carbon isotopic composition. In this way, 3I Atlas became a messenger carrying the chemical fingerprint of another region of the galaxy. Comparing such signatures from multiple interstellar objects will help map the composition of the Milky Way in an unprecedented way. The discovery also underscores the power of the James Webb Space Telescope. Although designed to peer deep into the primordial universe, Webb is proving capable of exploring our own cosmic backyard, where mysterious objects like 3I Atlas lurk in the shadows. In this case, it was infrared vision that turned an obscure speck into one of the most important interstellar discoveries of the decade. A vivid clue to the chaos, evolution, and chemical diversity at work on a galactic scale. The scientific excitement surrounding 3I Atlas stems from what it represents: the remarkable resilience of planetary material. An object that can wander through interstellar space for millions of years, enduring cosmic radiation, micrometeorite impacts, and the cold void and yet remain intact suggests that planetary systems have created structures that outlive their parent stars. It also bolsters the long-held theory that planetary material ejected from star systems doesn't just evaporate into dust, but can persist as giant clumps drifting between galaxies and even helping to form new worlds. Months of data collected by Webb provide an unprecedented look at how interstellar matter reacts to sunlight. From the rate at which it sublimates to the changes in color and spectrum in its coma as 3I Atlas rotates, all of this makes it a living laboratory, allowing direct study of the chemical evolution of planetary relics beyond our own star system. In addition to its scientific value, the discovery has profound philosophical implications. 3I Atlas becomes a tangible link between star systems, reminding us that planetary boundaries are not closed. Matter, and possibly even the seas of life, are constantly being exchanged on a galactic scale. Each such celestial body tells a story older than Earth, carrying with it the remnants of worlds that vanished before the sun formed. Webb's ability to determine 3I Atlas's enormous size and delicate composition also underscores the importance of next-generation observatories. Future telescopes, both ground-based and in space, will be needed to track these rare interstellar travelers, analyze their composition in more detail, and one day even send probes to intercept them en route. All of this makes it a living laboratory, allowing direct study of the chemical evolution of planetary relics beyond our own star system. In addition to its scientific value, the discovery has profound philosophical implications. 3I Atlas becomes a tangible link between star systems, reminding us that planetary boundaries are not closed. Matter, and possibly even the seas of life, are constantly being exchanged on a galactic scale. All of this makes it a living laboratory, allowing direct study of the chemical evolution of planetary relics beyond our own star system. In addition to its scientific value, the discovery has profound philosophical implications. 3I Atlas becomes a tangible link between star systems, reminding us that planetary boundaries are not closed. Matter, and possibly even the seas of life, are constantly being exchanged on a galactic scale. For cosmic chemists, 3I Atlas is a veritable treasure trove. The isotope data alone open up new avenues to understanding stellar nucleosynthesis, how stars forge elements and distribute them across space. Each elemental signature on 3I Atlas is like a time stamp from an inaccessible corner of the galaxy, allowing us to deduce the types of stars that contributed material to its formation region. These details suggest that planetary geology in the galaxy may be far more diverse than previously thought, and that worlds in our solar system are just one of many possible evolutionary scenarios. This giant object, silently hurtling through the cosmic void, carries with it an ancient chemical history, far older than Earth itself. Its existence also underscores the limits of our observational abilities. A mass hundreds of kilometers across can traverse interstellar distances and only be detected near our solar system. It evokes a sense of awe at the vastness of the galaxy and the infinite number of worlds that could have formed and disappeared long before the birth of the sun. 3I Atlas seemed to be living proof of the powerful gravitational jerks in star system, where planets and moons can be ripped apart and flung into interstellar space as relics of cosmic chaos. Continuous monitoring from Webb revealed an unexpected thermal pattern. 3I Atlas retained heat for much longer than a typical comet or asteroid, radiating energy slowly and unevenly. This suggested a dense interior structure. a rocky or metallic core encased in thick layers of ice, consistent with the hypothesis that it once belonged to a larger differentiated body, such as a moon or a proto-planet, that underwent internal heating before being ejected. Even more intriguing, surface spectra show that minerals only form in the presence of liquid water or at high temperatures, suggesting that before being ejected from its parent star system, 3 Atlas may have undergone hydrothermal reactions under its icy crust. If true, this would be not just an interstellar visitor, but also an alien geochemical archive recording the same processes that shaped Earth's early oceans. The key question is how such a large object could survive for millions of years among the stars. The answer may lie in its crust itself. Under constant bombardment by cosmic rays, volatile ices sublimate and refreeze, creating a self-regenerating shield that protects the core from erosion. This mechanism allows 3I Atlas to maintain its internal chemical makeup almost intact, a perfect repository of extrasolar planetary history. For planetary scientists, 3I Atlas is like a lonely time capsule in the void, a pristine record of ancient conditions in a long-lost planetary system, and the surprises continue. As the object approaches the outer planets of our solar system, subtle changes in its orbit reveal that 3I Atlas's mass is significantly larger than its surface brightness, a sign that it is not only large, but also unusually dense. The implications are profound. 3 Atlas is not a porous comet, but a massive fragment of a giant world. Its mix of rock, metal, and ice recalls the structure of icy moons like Ganymede or Titan, as if a lost relative had the chance to develop into a planet before being ripped from its parent star. Confirming such a dense interstellar object requires a rewrite of classical models of planetary dynamics. Old simulations suggested that clumps larger than a few tens of kilograms would be held together by gravity unless extraordinary forces intervene. But 3I Atlas is hundreds of kilometers across and could only be expelled by an extreme event. The most likely scenario is a chaotic stellar nursery where young stars form in denser clusters. A close stellar encounter can tear apart entire planetary systems, sending baby planets and proto-planets into interstellar exile. In that picture, 3I Atlas could be a relic of a cosmic holocaust, bearing the scars of a violent past. Webb's constant observations revealed more secrets. The object's light curve changed periodically, reflecting a rugged surface of mountainsides, basins, and deep faults. Infrared images showed reflections from steep ice cliffs shimmering as the object rotated slowly in the distant sunlight. These structures seemed to record a geological moment frozen in time. Cracks formed by tidal forces or collisions long ago now motionless in interstellar space. Each rotation of the 3I Atlas thus becomes a frozen map of the disaster, a panorama of alien terrain perfectly preserved over millions of years of interstellar wandering. The discovery of these geological features also sheds light on how interstellar bodies can influence young planetary systems. If an object like 3I Atlas were to pass through a protoplanetary disk, it could have acted as a catalyst for planet formation, seeding early worlds with heavy elements and complex molecules. The possibility of chemical or even biological cross-system contamination has become a central topic of discussion among astrobiologists. The possibility that interstellar travelers could bridge the chemical divide between stars makes the galaxy seem less isolated, more connected. Each such object becomes an emissary, not just from another system, but from a cosmic web of material exchange that stretches across many light years. As the telescope's data accumulated, astronomers began building detailed computer models of how 3I Atlas might have formed. One leading scenario: envision a young planetary system with a gas giant orbiting close to its star. A nearby stellar passage disrupted the system's outer regions, scattering moons and protoplanets. One of these objects, roughly the size of a small moon, was caught in the gravitational crossfire and shot off at interstellar velocity. Over millions of years, it drifted across the galactic plane until a fortuitous alignment brought it into the solar system. In that sense, its arrival was both fortuitous and inevitable. A crossroads of cosmic orbits pulled together by the delicate mathematics of gravity, The discovery has also sparked renewed interest in detecting similar objects. If Webb can capture detailed spectra from an object as distant as 3I Atlas, next-generation observatories could map entire populations of interstellar travelers. Wide-field infrared surveys could reveal hidden populations of large, silent wanderers traversing the voids between stars. Some may be temporarily captured by star systems changing their orbits or even colliding with planets. The realization that such events may be common has redefined the boundaries of planetary safety and cosmic interaction. One of the most intriguing aspects of 3 Atlas is its chemical diversity. Spectroscopy reveals not just plain ice, but also traces of metals like nickel and iron embedded in its crust. These elements often form deep within differentiated objects, meaning the object has experienced melting and material separation. It is a fragment of a world that has gone through the full cycle of planetary evolution: formation, differentiation, destruction, and exile. That history brings a new sense of grief to the discovery. This is not simply a rock drifting through space, but a survivor of the death of a world. Examining its structure, scientists noted that its outer layers contain crate hydrates, gas molecules trapped in crystallized water. These compounds are known to store volatiles under pressure, releasing them as the ice sublimates. Such materials would explain the intermittent jets observed by Webb's instruments. They also suggest that 3I Atlas's internal pressure remains significant, even after so many eras in space, a sign of its resilience and complexity. In planetary science terms, it's an active relic, not a dead piece of debris. The discoveries of 3I Atlas also resonate deeply with the broader goals of understanding planetary diversity. Each exoplanet discovered around distant stars adds a new example to the collection of cosmic architecture. But interstellar travelers like 3 Atlas offer something more tangible. They carry direct evidence, physical material that once belonged to alien worlds. By studying them, scientists gain access to the physical history of planets beyond our reach. In many ways, Webb's observation of 3I Atlas accomplished what decades of exoplanet research had dreamed of. It provided a sample of another solar system naturally delivered to our doorstep. The object's enormous size also reshapes expectations of the rogue planet population. If objects hundreds of kilometers across can wander through interstellar space, then even larger planetary relics might exist invisible until illuminated by a passing star. These could include entire rogue planets, gas planet cores, or icy worlds drifting in eternal night. 3I Atlas. They may be just the harbingers of an unseen multitude. Discovering and studying them could become a new frontier for astronomy, revealing how matter circulates at galactic scales. Webb's ability to analyze the object's spectral signatures has produced detailed thermal maps showing its thermal emission patterns. Surprisingly, these maps reveal small hotspots on its surface, localized regions warmer than the surrounding crust. These could be caused by internal heat trapped in pockets or slow chemical reactions occurring beneath the ice. Even in the near absolute zero temperatures of deep space, such warmth suggests stores of energy that could last for eons. The idea that dormant chemical or geothermal processes could continue in an interstellar traveler has fascinated researchers, raising questions about how dead these objects really are. The cultural and philosophical impact of the 3 Atlas discovery was no less profound. The image of a giant alien world fragment older than the sun passing through our cosmic neighborhood resonated deeply with the public imagination. It symbolized the endless continuum of matter and time, a reminder that every atom in our bodies and every speck of dust on Earth is part of a galactic story far older than humanity. In capturing its faint light, the Webb telescope essentially took a picture of history itself,